Okay, so just a quick introduction. I'm Ian Goldsmith, VP of Product Management here at Akana. And today we're going to talk a little bit about microservices. A slightly different perspective on microservices. What I'm going to do is walk through some of the sort of introductory material we have that talk about the classic view of microservices and what they are and some of that stuff. And then I'm going to sort of branch off a little bit and deviate and talk about a different way of adopting microservices that's a little bit more practical. I wrote a blog post a month or two ago titled "Eating Your Microservices Elephant One Mouthful at a Time," or one bite at a time. And that's really the topic and concept that I want to talk about here. I'm not convinced that it's practical for most organizations to take a comprehensive path to adopting microservices, i.e. A model where you re-architect an entire platform along microservices lines. I think there's another way of doing it where you can take individual pieces of functionality and turn those into microservices that you pull out of the application, and that's perfectly in line with the core ideas behind microservices around bounded contexts and all that kind of stuff. So anyway, without further ado, let's start sort of wading in and talk a bit more about microservices themselves and what they're about, and then we'll dive out of this deck into some demo and look at some stuff. Okay, so microservices, what are they? Been a lot of talk about microservices over the last couple of years. Really been around quite a bit longer than that, but I think the core definition from an enterprise architecture perspective is Adrian Cockcroft's view here: loosely coupled service-oriented architecture with bounded contexts. And we'll talk a little bit about bounded context and what that means. But really what it comes down to is that microservices are a new way of building applications. So break applications up into small, independent, individual services. Now there's a couple of very important words in there and immensely imprecise words. So small is a particularly imprecise word. But that's one of the words that we've used here. And then independent. What does independent mean? So the independent really means that the services function completely independent of each other. And in fact, you can go a bit further and say that each instance of a microservice is going to be independent of any other instance of that microservice. So it's kind of an interesting concept, and it brings along some baggage that's really pretty difficult to achieve. Some other things that you can sort of infer from a lot of the microservice definition discussion: no specific language, no heavy middleware, so that kind of leaves some of the ESB vendors scrambling a little bit. And there's a lot of open source in the microservices realm. There's a lot of libraries out there that people are using to build the infrastructure that supports microservices. And that's kind of an interesting concept. Why would you have infrastructure to support microservices? Well, we'll talk a bit about that. In fact, let's just look at an example. We've got a slide here that sort of highlights the microservices architecture and use by Pivotal and Netflix. So it shows a number of the libraries and the stack components that Pivotal and Netflix use as part of their architecture. Now, some of this may have evolved and probably has evolved in the time over the last year or so. But you've got the idea of a microservices registry where you've got things like Eureka, etcd, console.io, some pretty interesting tools that really provide basic key value, distributed key value lookup services for microservices to self-register and then applications to identify endpoints that they can consume microservices using. So it's sort of some interesting things in there. Very much not your father's UDDI registry for those of you who are sort of web services literate. It's a very different concept than that. Serves the same basic function, but quite different. You've got things like Hystrix for health and resilience. You've got load balancing. You've got auto-generation, proxy libraries, a whole bunch of different things that build individual microservices. And then you've got the languages and the technologies that are used to construct the individual things. And that's almost irrelevant. It really doesn't matter if you're building a microservice in PHP or Node or Scala or core Java, it really doesn't matter. There's a lot of different ways you can build these things. Go is a particularly popular approach. What's more important is the interface that you're exposing, and this sort of gets into the idea of bounded contexts, where the context of each microservice is going to be entirely independent of the rest of the application, sharing a defined interface. Now, a lot of this sounds a lot like SOA, well, because it is a lot like SOA. In fact, really what microservices is another way of thinking about SOA, and hopefully a way that allows service-oriented architecture as an architectural concept to get a little bit more traction. So anyway, another way of looking at microservices or what defines them, and this is sort of my personal definition here really, is that microservices are kind of a combination, or really the intersect of SOA, DevOps, and containers. So let's talk a bit about each of those. SOA is a bit of a controversial term. It really shouldn't be, because what you've really got is vendor-driven SOA and then SOA the way it should be. And I think I'm allowed to say that because I was one of the vendors that gave us vendor-driven SOA, which isn't necessarily been the most successful approach. But basically what vendor-driven SOA did was it gave us design by committee with things like SOAP and the complexities of the WS star specifications. It gave us the enterprise service bus, which was sort of, oh man, this SOAP stuff's kind of hard, so how can we make it easier for people to use? So, well, okay, we'll sell them these ESB products that'll make it easier to interface. And kind of built some complexity into the model as we went along, and in some ways helped ensure that a number of customers were going to fail in their SOA initiatives, and in other ways helped customers achieve a lot of success with SOA. But what microservices really are is a reaffirmation of the core principle of SOA, which is that you can break an application up into a set of individual independent services, and those services will deliver pieces of functionality to an application. Where there's some discussion and some debate, I guess, in microservices versus SOA is that the core premise in SOA was reuse. The idea was that you were going to create a service that would be of value to multiple different applications and would be consumed and consumable by multiple different applications. So think of a classic example. Maybe in the financial services space, it might be a currency conversion routine, currency conversion function, which ideally should be built once and then shared across multiple different applications via standard interfaces. And there are lots of other examples. Your customer database should and probably could and probably should be a service. Authentication, things like that. So there's a number of things of that ilk. But then when you start getting into microservices, people tend to think much more in terms of one application, thinking about it as, okay, well, I've got a piece of functionality in my application. I need it to scale to service the needs of this application. I need it to be global to service the expanding footprint of my application, but not necessarily thinking about that microservice in terms of supporting things outside one application. Now, I'd argue that there's really there's no reason not to implement microservices in such a way that they can service the needs of multiple applications, as long as you don't overcomplicate them in the process. And that can be very difficult when you have two or more different application architects arguing about specific functional requirements for their application and insisting that a back-end service services the specific aspects of their application as opposed to providing a general function. But that's a soapbox I could spend a lot of time on, so I'll try not to climb on it right now. What microservices did, though, was reaffirmed that core principle of breaking, of delivering application functionality as a set of services, and then it was a reaction to vendor-driven SOA. So it dovetailed in agile development. It brought in the idea of DevOps. We'll talk about that in a second. And it brought in the core ideas of domain-driven design with bounded contexts and eventual consistency models for data distribution, which becomes very important when you think about the global distribution requirements for a microservice, and particularly the kind of internet scale applications which tend to lead people down the microservices path. These kind of design concepts that are relatively new become quite important. And I think it's fair to say that microservices really is unabashedly an anti-ESB concept. And when we start talking in a few minutes about some of the, I guess we'll call them architectural guidelines that define microservices, you'll see why it's really pretty difficult to deal with the idea that an ESB can be part of a microservices architecture. And a big part of that is the idea that you have smart endpoints and dumb pipes, and a microservice an ESB is not a dumb pipe. That's sort of the part of the problem in core SOA, is that people began to build more and more business logic into the ESB, which is putting intelligence in the plumbing where it really shouldn't exist. So DevOps, what is DevOps? I'm going to take an incredibly simplistic view over here because I really don't want to get into a dissertation on that. But effectively, we're in a realm where the developer interacts directly with your infrastructure. So we could say you need fewer operations staff. We could also say that your developer teams include operations staff, which is a much better way of looking at it. You certainly cannot get rid of your ops teams. Your ops teams become an integrated part of your development organization. In the same way that Agile brought QA teams much closer to the development teams, where Agile teams, Scrum teams, can include QA, you have the same idea in DevOps teams. You have small teams that include the ops people. And what it means is that your developers are able to take new functionality directly, take it live directly into a production environment, obviously with appropriate testing and QA. But you are moving things into production much more rapidly. It enables a much more agile realm. But in order to do that, you have to ensure that if someone does make a mistake, it's probably not going to destroy your entire environment and break everything. And there are examples you can think of relatively easily. I mean, think about Netflix and their recommendations engine. It's not a disaster if you're logged into Netflix and you're viewing the catalog of movies, and when you look at one movie, if you don't see a list of associated recommendations, you should see, okay, it's not the end of the world. You can still continue to use the core product. There are other things that would be pretty fundamentally damaging if they were down, for example, an authentication service. So you need to think about what kinds of rigor you apply to different parts of your application. And the beauty of microservices rolling in or tying in with DevOps is that you can take that kind of approach, and you can think in terms of, okay, well, I can view some parts of my application as more agile than others based upon the requirement sets that I have. But effectively, DevOps is a way of streamlining your requirement to production process and getting things in production much more quickly. Agile development enables you to add functionality to your application much more quickly. Tying in DevOps means you can take that new functionality live in production much more quickly as well. So then containerization, that was the third part of my definition of microservice, the intersection of SOA, DevOps, and containers. And containerization, I would hope by now that most of you are familiar with that, but it's effectively a lighter weight way of deploying applications into machines. So effectively, in a virtualization world, you take a host operating system with a hypervisor, and you'd then have multiple different guest operating systems running in that as virtual machines on top of that host hardware. So you're basically sharing hardware with multiple different operating system instances running on that hardware. Maybe instances of the same OS, but they're logically separate instances of the operating system. And then each one of those operating systems could run one or more applications. And what that means is you've got multiple instances of the operating system running on a machine, which is inefficient from a memory and typically a processing perspective. And then you contrast that with containerization. And Docker obviously is the leading example of containerization that's out there. where you have a single operating system that's partitioned by a thin layer that then allows you to run multiple different containers that are logically separated but share a number of common components. So there are a lot of advantages. These containers tend to be much smaller and lighter weight. They're much quicker to deploy because there's a lot of shared stuff that's already running in the container host. They start much more quickly. And you can have many more of them on a single server because it's a lot more efficient, much more efficient model for deploying these. So we're starting to see a pretty rapid adoption now. It's taken probably a couple of years for containerization to really start to take off. And it's honestly, I thought it would happen quicker than it has. It's still not really as broadly adopted for mainstream applications as I was expecting, but we're starting to see more and more of that. Things like the Amazon Elastic Container Service and things like that make it much easier for people to start to use Docker in production environments, and we're seeing a lot more of that happening. So you end up with a combination of SOA giving you the core service-oriented architecture construct, DevOps allowing you to get things into production much more quickly, and containers that allow you to deploy smaller, lighter weight instances and deploy them and evolve them much more quickly. And those really provide the core three legs of a microservice. Okay, so let's formalize a little bit and jump back and talk about some of the key things that make up a microservices architecture. Term's been around a while. Sort of shows up in microkernel discussions from way back when. The architecture has been pretty heavily adopted in some of the bigger internet properties, Netflix, Google, heavy users of it. The first sort of, well, maybe not the first, but the seminal documentation around microservices is a really informative blog post from Fowler and Lewis. Very well written, very easy to read, and really pretty comprehensive. It gives a pretty clean and I would say relatively unbiased view of what microservices are and what they aren't. We're going to talk a little bit about the core architecture, some of the trade-offs, some of the capabilities, and then I think it's important that everyone really does keep in mind that microservices are just another implementation or another SOA driven concept. So I talked about this already, vendor-driven SOA versus microservices, two different sides of the same coin. The drivers around microservices are things like scalability, so the idea that I need instances of a particular service available globally and I need them to scale linearly as my application grows. That's probably the core driver. You've got things like Conways Law, which is the idea that the architecture of a piece of software will take the shape of the team that writes it. So you end up with your applications looking a lot like your organization structure. You've got a whole bunch of ideas around the composition of services that are highly focused, the agility of your development frameworks as it's become much easier to build things in a more agile way. And then sort of riding into all of this is some of the stuff that's now happening in the cloud and the ease of building things out in the cloud. Amazon will talk about Lambda as a primary microservices platform because it's sort of the idea that of just code snippets running in the cloud. It's kind of interesting. Okay, so let's look at some of the core principles. There are 9 principles that were espoused in the Fowler and Lewis post on the subject of microservices. And I'm not going to go into immense detail on all of these, but basically it's around the idea of organizing your application around componentizing it via services. A lot of it is RESTful, but not necessarily. Organized around business capability. So instead of thinking about a technical function and creating a service for that, you think about a business capability and create a microservice for that. So it's about products, and again, that comes back to Conway's Law, and there's plenty of reading you can get into that. So don't organize around a project. Organize around a product. So smart endpoints, dumb pipes. Put the intellect into your endpoints. This one's kind of interesting because you do have to think a bit about where should some of the core infrastructure function exist. Should you be rebuilding monitoring and security into every single microservice, for example? Or should you have some kind of infrastructure layer that does that? And what seems to be happening in the industry around that is use of common libraries that offer those capabilities. But there's still a ways to go there. Decentralized governance. So rather than having a central enterprise architecture governance function, you build your governance into the service itself. So sharing patterns with core libraries, minimize your overhead, keep everything focused on the consumer. Now, the next point, number 6, is, in my opinion, far and away the hardest part of microservices architecture to accomplish. This is when you start getting into decentralized data management. So the idea that different microservices will always own their own data, and there won't be any kind of centralized shared data storage. Now, think about that, for example, in terms of creating 2 separate microservices, one for authentication and one for customer profile. Sounds like a sensible, smart thing to do, but now you're starting to get into the problem of joins. Typically, in a more classic application architecture, you would use a join in the data layer to ensure that key information managed in the authentication system is shared by the user profile. Or perhaps a different example might be a list of purchases that a customer's made as a separate service compared to their user profile. Again, you need to be able to kind of merge this information. But all of a sudden, you find you can't do that with joins at the data tier. Instead, you're forced to do your joins in the application tier, which gets much more complex and potentially introduces significant performance issues. The reality is that if you can achieve it correctly, and if you can architect in such a way that you can minimize the performance overhead of having to do it, you will achieve a great deal of scalability benefit. So you're really facing a trade-off between scalability and near-term performance. So it's kind of an interesting model. You're moving the problem to a different layer in the architecture effectively. And then the last 3 points are really about the core principles. So infrastructure automation, that's really a DevOps concept. You want to make sure that as you need to scale a microservice, you don't have to go manually building out servers and all that kind of stuff. It should happen for you automatically. As you recognize that there's a scalability challenge somewhere, you should be able to very quickly and easily spin up another instance of something. And then you also have to design for failure. You have to ensure that you're doing A/B testing and various things of that nature. You need to make sure that in the event that a piece of your application is down, the rest of the application can function where possible. So there's a lot of core capability in there. Then evolutionary design is really just an agile concept. So a few other things in terms of additional thoughts around microservices and what makes them appealing. Well, keep your team small. Your team should be feedable with 2 pizzas. So depends on, I guess, how hungry and how big your teams are. But you really need pretty small teams functioning around a single microservice. Microservices should provide one capability. So it's not about how big the service is. It's about the capability they're offering. So don't try and build a complete application into a single microservice. Build a microservice that delivers one thing for your application. And then this next point is pretty important. Each microservice has its own life cycle. So you sort of get out of the realm of every month or 6 months or year delivering a new version of an application. Instead, the individual components that make up that application can evolve on their own timeline. So you can add a new feature to the recommendation engine, or you can add a new authentication mechanism independently of the rest of the application as you move along that way. Communication protocol should be lightweight. So there's a lot of them about, lots of choices. We're seeing a lot of customers starting to think about using AMQP or Kafka as a model for consuming microservice. And I'll explain a bit about that. It's pretty interesting, the idea of using queuing for that stuff. I'll show why that's such a good model. In fact, I'm going to demonstrate that. Make sure you're using the right tool. Keep the data store separate. Design for failure. Talked about that already. And the microservice owners are responsible for the full life cycle. It's not just the development. That really is that core DevOps construct of development teams, including operations. Okay, so why would you do microservices in the first place? What is it about them that makes it interesting? Well, the funnel on the left is sort of is showing or each of these funnels really shows a product management process. So the funnel on the left is a product management process for a whole application with a big development team working on it. You've got a ton of requirements coming in the top, and they get filtered down, implemented, and then spat out the bottom on a release schedule. And it's quite difficult to manage that process. It's unscalable because as the requirements for the application grow, you end up with more and more things in that hopper, and it's harder and harder to filter them down and prioritize and determine what you need to build. And you get your release cycle of the application itself starts to consume an increasingly large amount of the development effort. So just the process of QAing the entire application, integration testing, load testing, all of these things for the whole application can start to take 3 out of 4 weeks in an agile process. So what you can do is move to a microservices realm where each microservice has its own set of requirements, its own development lifecycle, and it becomes much easier to manage them at that level. As long as you stick to that core idea of bounded contexts and the understanding that you have a contract as a microservice developer to provide a clean interface that the rest of the application understands and can use. So there's a lot of value to the idea that you can move in this direction, and I'll give you an example later of how we've done that with our own product set. So why is it hard to adopt them, and how hard is it to adopt them? Well, there are 4 things, maybe 3, but 4 things. You need to be mature operationally. So you need containerization, you need a strong DevOps process. You have to be willing to re-architect the entire application. Perhaps this is where I kind of differ from my own self here. I'm not convinced that I was right in this statement. And I think this is where the industry may be making some mistakes in microservice thinking. You do have to be willing to invest in the application. So you're not going to take a legacy application that you're trying to deprecate and start re-architecting the application or part of the application along microservices lines. But then realistically, in order to be contemplating microservices as development path, you really need the application to be able to scale. I mean, that's got to be your driving factor. Why would you do it in the first place? Because it needs to scale. It needs to scale either through global distribution, so you've got people all over the world that need to use it, or it just has a ton of users and a ton of use. So that last point is really why you would go down the microservices path in the first place. So in order to adopt microservices, you've got to meet a number of requirements. So then here's where I start disagreeing with myself. Incremental adoption is really the idea that you don't have to re-architect an entire application to start taking advantage of microservices. This diagram shows the sort of structure of the demo I'm going to show you in a minute, where we've got basically an application modeled in our gateway. And in fact, it could just be a business application at the back end that has a certain piece of functionality that it's been delivering, but now all of a sudden we want to take that piece of functionality out of the application and rebuild it because it's become a bottleneck. We've had customers with examples where they have a routing concept. So a ticket comes into their system and they need to determine where to route it, and their routing server became a bottleneck. So they can pull the routing server out and deliver it as a microservice consumed by the gateway. And the model I'm going to show is actually kind of interesting in the way we've implemented it, and we'll start getting into some code in just a second on that. But basically what we've done here is have said, okay, well, I've got a particular function, and what I'm going to do is have, when the gateway identifies that function needs to be invoked, it's going to put a message on a Cloud AMQP queue, which gets serviced on the back end by a number of worker processes running, in this case, in Heroku. Any one of those worker processes can lift the message off the queue, process it, generate a response, put it back on a reply to queue, which will then get picked up by the thread inside the application and returned. So the beauty of that is that any one of these components is independently scalable. If the queue is building up too much because there's not enough worker process on the back end to handle it, I can just increase the number of worker processes. Incredibly easy to do in Heroku. You just scale the worker processes by adding more. If the queue itself becomes a bottleneck, then I can simply grow my cloud AMQP footprint in this case, or my own AMQP stack. It's relatively easy to create clusters of AMQP servers. If the front end, in this case modeled by my API gateway, is the scaling problem, I can simply increase the number of instances of the gateway I'm using. It's a stateless application. So I can independently scale any of these. Then on the back end, for building the worker processes, I kept this very cloudy. I used the Cloud9 IDE to build the code, deployed into GitHub, and then I use a platform called SnapCI, which is monitoring GitHub, and when it sees a change, it redeploys the application into Heroku. So I've intentionally kept any workflow out of this, so any change I make in my development environment immediately hits my production environment in Heroku. You probably don't want that, but it's a pretty interesting example of how DevOps can play with automated deployment. So that's the diagram. I have a number of extra slides which we'll get back to if we have time at the end of the presentation. What I want to do now is just break out of the deck and show you what this looks like in the real world. Well, the real world being my world. Now, bear in mind that the code you'll see here is mine and mine alone. The company takes absolutely no responsibility for it, and nor should they. So if anyone feels particularly ill after seeing my code, then I apologize. But this is purely for demo purposes. Okay, so let's look at what we have. It's a pretty simple idea. I have a server, which is written, it's a Node server. It's written in JavaScript, or in Node specifically. It basically binds to an AMQP queue and implements a number of functions. In this case, I have 3 different functions running, which basically, when one of the worker processes pulls a message off the queue, it looks at the message and sees, okay, is this destined for one of these 3 functions? If it is, it runs the function and puts the response back on a queue. If it's not destined for one of these 3 functions, it returns an error. A very simple thing. So just to show you what that looks like, I'll just use a client running down here, and I've got a client application running also in my development environment just for testing purposes. So client.js, and I've got a hello function. So hello, Ian. And it tells me that I've got to wake up Cloud9. It's gone to sleep for a little bit. Once it wakes up, it'll tell me that it's executing that hello function with input Ian, and I get a response back. So likewise, I could say node client.js Fibonacci, and we'll try 10 as a good input to my Fibonacci function. And that should return 55 if my math is anything to go by. There we go. Okay, so it executed that function and got 55 back as a response. So now if I tried something like Fibonacci, it should tell me that that's an invalid function. It doesn't know anything about that function. So there we go, got an unknown function name. Now, what's sort of interesting here is I can come along and I can say, well, I want another function. Akana.tester is function n, and I'll keep it very simple. Return tester input plus n. So basically, I'm going to take the input to the function and return it as part of a response string. So it's not really a very sophisticated piece of code. And I will add that change to GitHub. I'll commit it, adding tester function, commit. Now, there's a small bug in Cloud 9's GitHub support where push doesn't actually work from that client, so I'll run the push down here. Git push. That pushes the function out to GitHub, deploys it, so that's gone out there in the wide world. And now if we come to, so if I go look at my repository over here, you should see a new commit. And it's adding a tester function, which it's dropping in there. And I should now be able to come back to my client here and say client, node, client.js, tester, Ian. Well, if I could type, it would have worked a little better. Node. And so once this responds, we will see that my tester function should have been invoked. Okay, we did. Oh no, got an unknown. Oh well, let's try it with a lowercase t. There we go. So my new function, yes it is deployed into one of the worker processes. In this case, there's actually only one worker process sitting on the back of that whole thing. But you get the idea. I could very easily scale that instance by. Actually, I'm going to do that in just a second. So I'll pull a local window over here just to sort of give the idea. So let's see. Just simply using Heroku's PS scale command, I can set the number of worker processes to 0. So now with the worker process to 0, if I rerun this call, it should tell me that it's executing the tester function, but it doesn't get a response because there's nothing sitting on the queue listening for anything. I can look at my Cloud AMQP monitoring screen, and I'll see a message that should get added to the queue. This thing's a bit sluggish to refresh, but we can see there's currently one message on the queue. If I turn the number of worker processes back up to 1, I'll turn that on, and when I come back here, I should get a response once the worker process picks that up off the queue and responds for me. There we go. So it reacted. So I can change the scale of the back end. I can change the size of the pipe. And then let's look at the front end. So the front end in this case, I created a simple API using our developer portal. I'll log in here. And logging into the developer portal, I created a service called Microservice Frontend. Looking at its details, it's not sophisticated. It has a single operation. I can look at the definition of that operation. It has a name path parameter and a number query parameter. Those are really the only parameters I'm using. I didn't specify any models. I kept it very simple. I can see that this thing has one implementation, which is currently hosted in Miami, by the look of that. It's actually sitting on my laptop. I just chose not to specify the location correctly. And I can then, in the next version of the product, which will ship in a week, I could go and look at the orchestration that sits behind that directly from within this UI. But currently, I have to go back to a separate UI on the API gateway to look at that. So I'm going to dive in, look at the implementation of my live API. And here's that same operation. And I can look at the process that sits behind that. So I have a very simple little orchestration that runs. What I do is I take the inbound message and I normalize it. Now, what normalize means is I look at all of gather all the parameters and all of the body parts together into a single accessible instance. So in this case, it's grabbing the path parameter and the query parameter and making them visible. I then run a script which just simply stores those processes in a couple of different variables inside the process context. Then I split the process into two parallel invocation threads. And in one thread, I run my microservice invocation to invoke hello using one of the using the hello parameter, the name parameter, and return that into a response. And then in the other thread, I invoke my Fibonacci function using the number parameter and return that. And finally, I use a free marker template to very quickly and easily construct a JSON response from the content that comes back from those two function calls. Now, it's kind of interesting, right? Because what I'm doing here is I'm parallelizing my process. So if I, for example, had a function that needed to create an aggregate customer record, and I had a whole bunch of different back-end data services that could provide different parts of that customer record, instead of having to go call all of those different services in series, I can now call them in parallel and bring all that information back together in one go. So it really optimizes the performance and speed of the application for the front end. Now, I've been experiencing a minor issue here, so let's see if I've got this live right now. I do not, so give me 1 second. I will fix this. I have to just restart something. So just coming back to this process, what we're going to see here when I invoke the process is that I get monitoring data picked up and generated in all sorts of places. As of right now, I haven't defined any security for this API. I can come back and look at the API implementation. The only policy I've defined here is a detailed auditing policy. I could very easily add cause policies, OAuth, application security, a whole bunch of other policy types that we have available through the platform. And these are just sort of simple examples in a demo environment. When I invoke this now, with a little luck, it hasn't finished its restarting process yet. Let's come back and look at the documentation for my API. One of the nice things about the platform is that anything that I specify in the details for this service appears in our documentation. So I kept the documentation pretty simple for this API, as you can see. But I have a built-in test client that I can use to invoke the service. So instead of just invoking it from, I've definitely got something broken here. I'll have to take another look at that later. But what you should have seen is a response aggregating the connection between or aggregating the responses of the Fibonacci call and the name call into a single response, and giving you back a JSON document that would have contained the two things. As it is, we don't, because of something I've done wrong somewhere in my configuration. Serves me right for doing a live demo during a webinar. But you can see, actually, what we should be able to see at least, is through the portal, I should be able to see the logs for the transactions that are coming through. So I have the errors showing up in here. I see the faults. I see the problems. I'm just not I'm not seeing why I'm getting the issue. So I've got a problem that I've broken somewhere in my system, and I'll debug it later. So what we can see is that the backend service is being called. It's responding in 3 milliseconds, and then I'm failing to aggregate the response correctly. And I'll have to check and find out why that is. So that's basically what I wanted to highlight. I wanted to really showcase the split join concept as a mechanism for invoking multiple different microservices on the back end. So again, that's this idea that a call comes in to a gateway. The gateway breaks out a piece of functionality and invokes a microservice through AMQP serviced by a bunch of different back-end worker threads, and showing how a DevOps process using various cloud tools can very quickly and easily be used to build those worker processes. Okay. I've got a few more slides I can cover. I'm going to skip a bunch of things, although I'll sort of jump on this slide very quickly, just to sort of show that one of the main things that sort of worries people with the idea of microservices and DevOps is that you tend to think of it as testing in production, but you're really not. You're testing small pieces of functionality in a development environment and then are moving those pieces of functionality into a production mode independent of other pieces of an application. So it's not really something to be particularly concerned about. It's certainly something to consider in the way that you construct the bounded contexts in your domain-driven design for the microservice. So let me jump back to the slideshow. Okay, so just sort of the final few slides. If you're starting from scratch and you haven't you haven't got an application yet, it's quite easy to start with microservice. But transitioning to a microservice application isn't easy. So you have to have a lot of discipline to break up a monolithic application. And you're almost certainly going to find that the hardest part's going to be, as I said earlier, moving joins to the service layer and out of the database. So separating your data. And then geographic distribution is not easy. Figuring out your sharding model is not an easy thing to do at all. And so those are probably going to be the biggest concerns that you have. There's a tweet here from Architect Clippy that is typically snippy for an enterprise architect around poorly structured monoliths and poorly structured microservices. So bear that in mind. If you start with something bad, you're probably going to end up with something bad. Okay, so let's look at our example and how our platform has transitioned over time. So there are two sort of core components to our platform, an API gateway and a developer portal. And the way that the platform used to work is that we had those two products really quite tightly integrated, surfacing about 40 different APIs. And the APIs are internal APIs that the platform itself is built using. That's not including the APIs that it's designed to surface, so customer APIs. A combination of the portal and the gateway would share a single database instance, and then for geographic distribution, we would simply have multiple instances of the portal and the gateway with their own database. So logically distinct instances that did not really share configuration data. So step one was to break those two applications up into a set of 5 different applications that they still publish about 40 plus APIs, but those APIs are now distributed across those applications, and they have much more clearly separated data stores. We started using NoSQL to get geographic distribution and replication and sharding in play, and we implemented a read-only slave model for using the SQL data store that makes it much easier to break that up. Now we're in the process of phase 3, where we have the platform delivered as a set of microservices, each with its own data, using sharding and replication for geographic distribution. And as part of that, we're now able to comply with international data protection laws, because we can ensure that data that for one particular region remains in that region. And there's quite a lot of sophistication in the way the platform has to be delivered to accomplish that. But what you end up with is a single, at this point, what you now have is a single logical platform that's distributed across multiple continents, multiple different distribution, multiple different data centers within each continent, but still a single logical instance using eventual consistency to ensure that everyone has the same view of everything in near real time. And then the final stage is as we begin to use container technology rather than raw Java deployments for each of those application sets. And we're in this transition at the moment, so moving towards using containers for a number of the components, which allows us to be even more agile in our DevOps process. And that's kind of I think the end state goal. And this is just our platform, the way that we're building out the cloud infrastructure that we deliver to the market to enable our customers to service and manage APIs. And with that, I think I'm out of slides, so I'm going to transition to a final slide and ask for questions. I can probably take a few questions if anyone has any.
There are questions for you in the quick Q&A box and the chat box.
All right. So let's see. Yes, my title probably should read Microservices Principles. Where is the Q&A box? Oh, there it is. Q&A. Here we go. Okay. Yes, it's recorded. Let's see. That's a very good question. Decentralizing data management, how does that fit in MDM, in a Master Data Management Initiative? I would probably not try to apply microservice principles in MDM. I think the two are quite distinct. I don't think there's any particular reason you cannot, because you can still continue to use things like the NoSQL models of eventual consistency, sharding, etc., to distribute your data effectively, and then have that data served by a set of microservices. But I think you're then thinking about a slightly different model where the microservice is just a processing entity. So it's kind of it's a different model. I'm not sure the two necessarily go hand in hand very well. The next question I see here is along similar lines, managing data store scalability when building microservices. So, I mean, what we did in our world is, as I kind of mentioned, we pulled a lot of the data usage out of the SQL store into a NoSQL store that then allowed us to use a very sophisticated sharding strategy to ensure scale of the collected metrics. That's what we use it for, collected metrics and runtime data across the globe. So it gives us a pretty it gives us the flexibility to use it, but you are still at one level limited by the scalability of your core data store. As I said earlier, it's the hardest problem to solve when you're dealing with a transition to microservices. And I don't really have a good answer for that. I think it's going to vary for every application as to how you approach that problem. Let's see. Okay, so in the one of the questions was what's the API management tool? That's the Akana platform. So you can check it out at akana.com. There's a free trial available, and you can create your own tenant and use your API platform. It doesn't really matter though. You can use any API management tool that has the ability to create lightweight orchestration and allow you to easily invoke services over AMQP queues. And in fact, I should have mentioned, if you check out github.com/Akana Inc., you'll see a repository, a public repository for microservices demo, and the code that's running in this application is available in that demo context. And if I find what I did wrong and fix it, then I'll let you all know, and hopefully you can check out a new version. Let's see, microservices or micro APIs. I'm not sure that there's really a distinction. I think that when we think about SOA, APIs, and microservices, in fact, I think I may have a slide on that. Give me a second here. Here we go, yeah. So SOA about reuse. So building services supporting multiple applications. APIs are really providing a back end for web and mobile application. It's about integration, so geared towards easier and better consumption of services. And then microservices are about agility and scale. So I would argue that a micro API is a specific instance of a microservice that is directly supporting a web and mobile application. What you tend to see is something like the example in this diagram, where an API consumed by your applications is actually fronted by an API gateway that may in turn be invoking multiple microservices in order to surface that API. But I think that's kind of the question there. Let's see, why might microservices and ESBs coexist? That's a good question. I'm not sure that the current generation of ESBs is architected in such a way that allows them to really participate effectively in a microservices architecture. I think the tendency with an ESB would be to build too much logic into the ESB. And remember that the ESB isn't supposed to be an application platform. It's supposed to be an integration platform. And one of the fundamental principles in microservices is that you have smart endpoints and dumb pipes. So making the pipe, i.e. the ESB, smart is probably not a good idea architecturally from a microservices perspective. Let's see. Do I recommend a gateway and management tool above all the microservices? Depending on what you're trying to do with it, yes. If you've got a lot of microservices that are directly part of an internal application, you don't necessarily need a gateway. And in fact, you probably shouldn't use a gateway. If, on the other hand, you're using a number of microservices to satisfy external applications, then you almost certainly need a gateway at the edge of your network that's surfacing the API that in turn is consuming those internal microservices. So I think that's probably an interesting distinction. Now, I think the last question I have time for is why we went for container adoption in the last phase and rather than earlier, and that's really just the question of timing and when containerization made the most sense for us. We had a lot of DevOps automation already. We had a very efficient way of deploying code into our data center providers via their APIs. And so the containerization of our platform wasn't as important at that point. As the containerization technologies become more efficient and it's become easier for us to do that, we're starting to adopt that. That's really the answer to that question. And with that, I think I am out of time. I'd like to thank everyone for taking the time to join me today, and we'll make the recording available. Thank you all very much.
Thank you.
The leader has disconnected. The conference will be terminated in 5 minutes.